Hello and welcome to another video. Today I'll walk you through the integration of the Light Tiles Crestron Home driver. This driver allows us to add different native lights UI components into a Crestron Home system and connect them to existing drivers using the Actions and Events framework. The main benefit here is that drivers which previously did not have native lights UI components can now be visually represented in the Lights section of the Crestron Home app. This makes them eligible for global lighting scenes and significantly improves the overall user experience. In this example, I'll be linking the Light Tiles driver to a Rhombus driver that already has lighting-related functionality. This is just a demonstration setup, but it clearly shows how different drivers can be connected and work together. Let's start from the beginning. First, add the driver to the room of your choice. You'll find it under Drivers, then Platform, then UI Tiles, and finally, Light UI Tiles Pack. Give the driver a descriptive name and confirm by clicking OK. In the next step, you'll be asked how many extensions of each type you want to include in your project. This driver supports up to 50 extensions per type under the same license. If you ever need more than that, feel free to reach out and we'll figure something out together. For this example, we'll simply add one extension of each available type. Under License Key, you can enter a license purchased from our store, but for testing purposes, you can also use the free 60-minute trial license. Once the driver is added to the room, the extensions are automatically generated. You'll find them in the root folder under Managed Platforms. From there, select the driver using the name you assigned earlier. As expected, you'll see 4 different extension types available. We'll start with the basic on-off extension. This component can be used, for example, to control a relay for simple lighting on and off functionality. At this point, the driver exists only as a UI component, so we still need to give it actual behavior. To do that, we go to Actions and Events, navigate to the room where the driver is located, open its folder, and locate the turned on and turned off events. These events can then be connected to actions on another driver that actually controls the physical lights. If you also want to update the state of the UI component based on feedback from another device, you need to trigger state changes using external actions. In this example, I have added a quick action just to demonstrate how the state update functions work. Other components support even more state updates, which we'll get to shortly. If you now open the Crestron Home app, you can already see how this component looks visually and how it automatically appears in the Lights section. Next, let's move on to the dimmer component. In addition to on and off control, this component includes a slider for fine light level adjustment. After adding the extension to the room, we again go to Actions and Events. Here you'll notice an additional event called Level Changed, which is triggered as soon as the slider is moved. At the moment, there is no direct way to pass numeric values from one driver to another through Actions and Events. Because of that, we need to rely on conditional logic using if-else states. For this demonstration, we'll quickly set up a few example conditions to show how different states in another driver can be triggered based on the dimmer level. How precise this mapping is depends entirely on you and on how accurately you want to react to changes in the dimmer value. One important thing to note is that dimmer level comparisons must use decimal values between 0 and 1 as defined by the Crestron Home SDK. You can also combine conditions using or and expressions to fine-tune the behavior of the UI component. You can see how this is set up here, but I'll leave the exact logic to you. The key idea should be clear at this point, so I won't go deeper into the specifics. Back in the app, you can now see the dimmer component linked to an external dual white component. This combination is just for demonstration purposes, and it's unlikely you'd use these two together in a real project, but it shows the flexibility of the system and what's possible. In the next step, we'll add the remaining extensions, dual white and RGBW. For the dual white UI component, we need to define the minimum and maximum color temperature range, as this is directly reflected in the UI. Once that's configured, we can immediately check how the components look in the app. Finally, for the RGBW component, I'll show how its color can be updated programmatically. To demonstrate this, I'll use quick actions to change colors, adding a small delay between each change so you can clearly see the transitions. In the app, you'll notice that pressing the quick action button updates the UI component's color accordingly. And with that, we've reached the end of the video. Now it's up to you to explore everything this driver has to offer. You have a trial license available, so feel free to experiment and play around with it. If you have any questions, don't hesitate to reach out. We're always happy to help. Thank you for watching, and I'll see you in the next video.